I'm going to discuss a Jupyter Notebook and the corresponding uh, Python code to basically create a script that does live video capture and processes the images by running them through a pre-trained CNN. In this case, the CNN has been trained to detect two classes, cat and dog. Before I take you through the details and run this, I want to kind of go through. Um, this assumes, of course, you already have a pre-trained CNN and you've saved it somewhere. The first step here is installing packages. The second step involves importing different dependencies and defining some parameters and setting up logging. The third step defines a series of functions. 3A dealing with loading of our pre-trained model, B dealing with pre-processing of our image, getting it ready to take as input to our model, and then lastly some functions dealing with prediction and making decisions. Step 4 involves loading the pre-trained model, as we'll see later, and then step 5 has us with a function called stored live predictions, which will display, which will save the image frames and the corresponding information in a file about their label. And then finally, we have the actual video capture loop here using OpenCV to capture and process the images. So let's go through these steps one by one, starting with the first one. I'm not going to explain this. You've seen this before, installing packages and importing dependencies. Here in this second block of step 2, we're defining some different parameters. In my case, the model I have here for my CNN is 150 by 150, and its color is the images, so it's 150 by 150 by 3. If you have a different model, takes different size images, then you'll need to change that accordingly. Some other things in here is the location of where I'm going to be storing my base directory, storing results inside of here. You have a results directory, as well as where I'll find my model. Verbose is something you can turn on and off, 0 or 1, and it will print different things. And logging to a file will print some things to a log file. And then finally, this decision, I call it decision difference threshold. We have a 2-class problem, so basically the highest class has to be higher by at least 0.2, and the output is again from 0 to 1. That's kind of an arbitrary value, but in order to make a decision, if it's within that value, then I'm going to say the decision is unknown. The next block sets up some logging to a particular file with a unique timestamp in the name. And so let's go ahead and run these series of blocks in our step 2. The next thing is basically just defining a series of functions. The first set of functions, there's 2 of them, whether or not you want to load your file from an H5 file. So this is assuming you have a TensorFlow Keras model, and you can save that with either an H5 or save it to a saved model directory. So depending on which one you have, which one you want to use, you can use either of those functions. The next set of functions have to do with, there's 2. One, a function that just only resizes the image. I use that. It just calls an OpenCV call and resizes the image shape to image shape, and that's just for display purposes, as we'll see below. But there is another function called preprocess that both does the resizing, which is necessary for the input to the network, but also does the division by 255 because our model was trained with an image data generator that had a rescale factor of 1 over 255. So instead of the pixel values going from 0 to 255, they go from 0 to 1.0. So they are actually floating point values. All right, the next set of functions here Predict is exactly that. It's going to make a prediction given you have an input, an image that's been pre-processed with the previous function, and then a model that's been loaded. The first thing it has to do, and this has to do with the shape of my CNN, but most CNNs, when you train them, you'll do with batch training. So the tensor shape that's input will actually look something like this: the height and the width of the input image, the number of channels, which is 3 for color. But in our case, we're going to be running with a single image, so the batch becomes 1. So we actually take our input and we create an expanded dimensions, an extra dimension. This becomes our tensor input. Then we simply call with that tensor input on the model the predict method, which is part of the tf.keras package, and it returns an array of predictions. And the length of the array is the number of classes that you trained with. In our case, it's 2 for cat and dog, and then I simply return it. Later, we'll pass these predictions in to make a decision, and this is very specific, obviously, to the model that I've trained. And we're going to return in a label of either cat, dog, or unknown. Basically, the first position in the array indicates cat. So if it's greater than the second, which is dog, and the difference of them is greater than our threshold, I'm going to label it as cat. If not, if the first, the cat value is less than the dog value, and the difference between the dog and cat is greater than the threshold, I'll label it dog. Otherwise, I'm going to label it as unknown. All right, this is a little block here, step 4, simply to load the pre-trained model. I'm assuming it's in my base directory, and the name of my model in this case is my H5 model, so I'm going to call the load model from H5 file. And part of what that will do is print out a summary, so you can see this is the structure of the cat-dog CNN, and we've talked about this before. The next step here is, so let's actually stop and let's go back and let's run each of these. So we stopped at step 2, so let's go ahead and run. These are just a series of functions, and here we're loading up our model, and there you can see it print out. This is storing the information as we're doing live predictions. And so what will be passed is the label of the decision, the prediction vector, the original image, and the directory where we want to store this, and then a file handle to a results file that has been previously opened where we'll write textual information. So this is just printing out some information to the console, but what I'm doing is creating here in this second piece a unique image name in our results directory based on image underscore timestamp.jpg, and then we are going to write the image using OpenCV call to that file name. And then with the file handle that was previously opened and passed to this function, we're simply going to write a single line representing this prediction, which is the label, the prediction vector, and then finally the file name of the image, including its path. So let's go ahead and run that. And so what you see me here doing in this next block is actually setting up the names of our files. So our result file is going to be called live results underscore with a timestring.txt, and we are opening up a handle to it and writing at the top new results. And so let's go ahead and run that. And so you can see this is, it prints out both the directory where the results will be as well as the results file name. So now we finally come to the live capture video loop. So it uses OpenCV. In fact, this is the handler for doing video capture. This makes sure if it's actually open, tries to grab a frame and display a preview. While I'm still capturing, you can interrupt this by stopping the kernel or hitting a Control-C. But what this will do is it will cycle through. In step 1, it's going to actually, again, read a new frame. It converts it from BGR, which for some unknown reason OpenCV captures in, and converts it to RGB, which is what we view images in and what we trained our model in. And then we're going to go ahead and display the preview. But immediately after that, and what you'll actually see is I am displaying the resized version just to see what is going to go into the model. Step 3 is where I actually call the preprocess image function, which will return the new image, which is in our case 150 by 150 and scale divided by 255, so it's actually floating point values. This calls the predict function with the model that we loaded previously with this new image scaled array, and the output will be an array of predictions. And this is just logging it out. The make decision is called. Now what you'll notice here, it says prediction 0 because the actual predictions array, if you look down here, is actually an array of the vector. So to get to the actual predictions array, we have to say predictions of 0. So we pass that to make decisions. And similarly, after that, we call store live predictions with passing the label, again, the prediction vector, the original image for storage, the result directory, and the file handle. So let's go ahead and run that. All right, so now you can see it's doing kind of a live, not quite real time of me. It's kind of going back and forth between cat and dog. It doesn't really know what I am. Let's go ahead and show it a picture of a cat. I'm going to use my phone. So you notice it's now at 0.995.02, so that's cat. Let's go ahead and do a dog. And let's zoom in on a dog picture. And hopefully it's going to know it's a dog. And now it's almost 0 and then 0.999, so it thinks it's a dog. Okay, so looking at our directories, I'm going to stop this and interrupt the kernel. And what I am going to do now is show you the information that got stored in my results. So a bunch of images. There's me. Towards the end, you're going to see the dogs and the cats. So let's try to remember this. 81206. Actually, not sure. Let's look at the timestamp here. Okay, so this one. Let's search on 8206. I think, what was that called again? Let's go back. 81206. 81206. Okay, so this is the file name. This was the prediction. So it really thinks it's a cat. And then there's the dog, and there's the label cat. Sometimes it's unknown, like if you're looking between the front, it thinks I'm a cat, then it doesn't know. You see these are about equally weighted, and then it thinks I'm a cat, and then it thinks it's a dog, and then it thinks it doesn't know. These are images of me, so it's kind of confused. Here's a bunch of unknowns, right? So you can see what's going on. And the nice thing is you can change the format of what's being printed out here. This is just something I did, and here's the actual live images. And every time you run this again, you'll get a new image with a new date stamp, so it'll be unique, and you'll get a new live results file. All right, thank you very much.